Hello, my name is Desmen Boykin, and I hope everyone is safe during these times. I really wanted to give this in person, so I'm doing a video. The title of my experiment was Bioplastics, Do They Live Up to Their Expectations? What are bioplastics? You may have seen these in your local stores or restaurants. They're any plastics that are made up of at least 20% plant-based material. You may be wondering, what's the difference between your average plastic and bio-based plastics? Bio-based plastics are made up of at least 20% plant-based materials, while the average plastic is made out of petroleum, and that petroleum is bad for our environment when it breaks down and can even take up to 800 years to break down, while these new plant-based plastics can take up to a month to break down, which is very good in some cases. The purpose of this experiment was to see if plant-based plastics are better than their petroleum-based counterparts. In this experiment, 3 different types of bio-based plastics were used: sugarcane, cornstarch, and wheat. They were all forms of polylactic acid, also known as PLA. For the sugarcane plant and the corn, starch was extracted and formed into lactic acid, then goes through dehydration and forms an oligomer. Then through thermal cracking forms a lactide, and then goes through polymerization and forms polylactic acid. For the wheat, the grain of the wheat is harvested, ground into a powder, then mixed with a synthetic polylactic acid. Then it is molded into the straw. For this experiment, it was hypothesized that out of the 3 different bio-based plastics, if the cornstarch was used, it would have the most negative effects on the Nelumbo nucifera plant, since corn is a commonly genetically modified plant. The dependent variables in this experiment included the pH of the solutions, length of the lotus sprouts, amount of chlorophyll in pads, total sprouted seeds, surface area, and dried biomass. The controls in this experiment included tap water with no plastics added, and the constants were 0.25 grams of each of the bio-based plastic polymers. For this experiment, I grew the lotus up to the lotus pad formation, and not the flower, because the flower takes around 4 months to develop. The lotus seeds. 16 seeds were placed in a lukewarm water vessel, and the seeds that floated to the top were not viable, while the seeds at the bottom were healthy and will be used in the experiment. 4 vessels with 1 liter of tap water was used, and 16 seeds were placed inside each vessel. For the total sprouted seeds, 81% of the seeds sprouted while 19 did not. Out of that 19%, 8% was the cornstarch and 2% was the sugar. For the length of the lotus plants, on day 3 through 5, the length of the cornstarch was the highest amongst all of them, but slowly decreased until day 17 and became the worst, while starting at day 7, the length of the sugar base slowly increased and became the best by the conclusion of the experiment. For the pH of the different solutions, there was a common drop on day 3 and day 13. The drop on day 3 may have been due to the seeds sprouting open and releasing chemicals into the water, while on day 13, this was around the time when the lotus pads started to form, and when the pads undergo photosynthesis, they can also release carbonic acid into the water, thus making the solution more acidic. For the relative chlorophyll content in the lotus pad, on day 13, the sugarcane base had the highest relative chlorophyll content, while at the end of the experiment it had the lowest chlorophyll content and the wheat base had the highest. To determine the specific leaf area, the leaf surface area and the dried biomass was calculated. The reason the dried weight was used instead of wet weight was to keep it constant throughout all of the leaves, since some leaves may have intaken more waters than others. For the specific leaf area, the wheat-based solution had the highest specific leaf area, while the water had the least. Some interesting things found in this experiment included the change in the solution, which went from clear to a dark brown, and also disintegrated plastic found on the leaf pad. And I was not able to make the plastic this small, so this shows that this plastic is disintegrating, which is a very good sign. These pictures are pictures of each of the lotus pad leaves taken at 1,000 times magnification, and they also show similar results to the specific leaf area, where the water has the least cell integrity and is most unhealthy, while the wheat-based has the darkest green and is more healthy than the others. In conclusion, my hypothesis was partially correct. No one plastic did better than the other, but they all affected the plant at various stages of its growth. And I think the scientific community is making progress with this plastic problem, but we still have a long way to go until we can make these plastics not affect any life at all. Thank you for letting me share my experiment with you, and I hope everyone stays safe during this pandemic.